Hi, welcome to the presentation of our paper, Is It My Turn? Assessing Teamwork and Taskwork in Collaborative Immersive Analytics. My name is Michaela Benk. I will be presenting this work today together with my co-author, Raphael Weibel. Collaborative Immersive Analytics is an emerging research field that has the potential to facilitate and transform collaborative work. However, there are a number of research challenges that the field is currently facing. They include defining appropriate application scenarios, designing systems that also integrate traditional tools and interfaces, as well as assessing all the dimensions of collaborative work. A promising application scenario for collaborative immersive analytics is machine learning interpretability, which refers to the development of methods to validate ML models, explain their inner workings, and their predictions. Such methods include visualizations of model outcomes or counterfactual explanations. Existing interpretability tools are usually displayed on 2D screens, comprise multiple interactive functionalities using keyboard and mouse input, and involve single users. It remains an open challenge how to design systems for industry-relevant and realistic CIA applications that focus on ML modeling and promote collaboration among the members of interdisciplinary teams. In our work, we tackle this gap by introducing an AR-based system for collaborative immersive analytics that is designed to support ML modeling in interdisciplinary teams. We conducted a user study to examine how collaboration unfolds when users with different professional backgrounds and levels of machine learning knowledge interact in solving different machine learning tasks. Finally, we make recommendations how immersive systems should be designed to elicit sustained collaboration in ML modeling.
Next, we give an overview of the system as a whole and then of the augmented reality application that we used for our user study. Here you see an overview of our system. In the center, you see two users, for example, a data scientist and a risk officer. Both wear a Microsoft HoloLens 2 on which our augmented reality application is running. The application allows both users to interact and manipulate with the visualizations shown at the shared workspace. Both HoloLenses are connected to a backend server, such that the visualizations are synchronized across both HoloLenses. In addition to the shared workspace, each user has a personal workspace, which is only visible to that specific user. Additionally, each user also has their own personal computer on which a web application is running. The web application allows to share information with participants through email or other web pages. To give you an idea of what our augmented reality application looked like, let us show you some of the possible interactions. The first interaction you see here is a user interacting with the data cloud by setting the desired variables on the axis and selecting a specific data point to receive more information. Second, you see an interaction with a counterfactual explanation of a selected data point. Using this system, we set up a user study. For our user study, we used a realistic industry setting. More specifically, participants were told that they work in the credit lending department of a bank. Each participant then took the role of either a data scientist or a risk officer at this bank. And based on their assigned roles, participants were then asked to solve a number of tasks which allowed them to assess the reputational risk of the algorithmic credit lending system. As we have these two roles that assume a different background, we also paired participants with two types of backgrounds, industry professionals and university students. The industry professionals were asked to adopt the role of a risk officer. The students were asked to adopt the role of a machine learning engineer. Here, an overview of the procedure. Once everything was set up, participants received instructions on their personal computers to start exploring the data by themselves at their personal workspace. After this first task, participants were asked to collaborate for the remainder of the session. Together, they were asked to further explore the data, build new models, and validate those new models using our system. During the user study, we had two main dimensions of measurement. First, we evaluated the teamwork using the pair analytics method by Hernandez and colleagues, which is suited for collaborative settings with two roles such as the ones we have in our study. Based on video and audio transcriptions of participants' interaction, we focused on three main variables: coordination of attention, pauses in joint actions, and navigation of joint actions. These variables were then used to evaluate the teamwork along 6 dimensions of collaboration, namely pair dynamics, division and allocation of work, common ground and awareness, references and elicits, incentive and engagement, and consensus and decision-making. In addition to the 6 dimensions, we also computed the times participants interacted with visualizations. The second main dimension was the taskwork, which was measured using questionnaires after task 2, 3, and 4. The questionnaires assessed participants' understanding and confidence in different models. In addition to the 2 main dimensions, we also recorded participants' thoughts on the usability and user experience of our system.
Next, we present selected results of our study. Our findings confirm that pair analytics can be an effective method to elicit collaboration for ML tasks in co-located synchronous immersive settings. As mentioned previously, the use of 2 roles, one subject matter expert and one visual analytics expert, are central to the method. Putting participants in the roles of risk manager and data scientist matched those roles well. The roleplay was intuitive and allowed users to share their mental models without interruption. We found that clear role division promotes effectiveness in solving ML tasks. This was shown by one participant taking on the role of managing the navigation of ML modeling tasks and the other participant taking on the role of driving and executing the tasks. We also observed that the visualizations could be misleading. For instance, in task 4, participants indicated to be more confident in a new model's performance, even though the accuracy of the model remained the same as the original model. Designers of CIA systems should thus explore ways to encourage critical thinking to avoid such overconfidence. Our results indicate that the use of multiple interfaces does not impede collaborative efficiency when solving ML tasks. Users could communicate and switch back and forth the different interfaces easily. In several sessions, participants asked each other for consent before interacting with the visualization. We found that such handovers are a dynamic of successful collaborations. Common ground between individuals could be interrupted due to difficulties such as uncertainty about the synchronicity of the visualizations or the content of the tasks, or difficulties in air tapping. It is important to consider mechanisms that allow to re-establish common ground when encountering such difficulties. Overall, participants were engaged and immersed in the visualization, with the exception of a few technical challenges. The different interfaces did not reduce participants' engagement. In fact, the use of immersive interfaces along with traditional input tools, such as keyboard and mouse, may have supported the realism of the study. Additionally, participants' user experience ratings were in an acceptable range. To conclude, collaboration in machine learning modeling is characterized by several challenges. They include the complex nature of ML tasks and the interdisciplinary approach in real-world ML applications where domain experts and ML experts with different skills have to collaborate. Our CIA system is a first step towards solving these challenges. It can elicit sustained collaboration among users during ML modeling. We expect our findings to be especially relevant for interdisciplinary teams in real-world applications from industry. As such, CIA systems may help reduce the complexity of ML modeling among the broader workforce. Thank you for your attention.